Okay, so we're looking at the solving some more complicated problems using Python in this lesson. And let's say we have this problem here that we've been given. So we want to determine how many cans of paint we might need to paint a wall in a house. Okay, and I can pick the size of the room and the number of coats I want to paint the wall. Right, so sometimes dark colors need more coats, light colors might not need as much, but typical 2 coats of paint probably to paint a wall on our house. Okay, and I know that the paint will cover 4 meters squared of wall space, and it costs $17.50 per meter squared for the paint. Okay, and there's going to be tax on the final price. So we want to basically create a little program that's going to let the user figure out how many kinds of paint they're going to need, and then what the cost is going to be. So you learned about in the lesson the concept of the input, processing, output model of problem solving. That works really, really well in this course in getting you to kind of think about what needs to happen in order to produce the code that solves this problem. Right? So we have to start thinking about what information do you need from the user in order to make this happen. And it looks like, since we're assuming we're just doing one wall to kind of keep it simple, and we might have to assume that the wall is rectangular, right, and not some crazy shape that we need to deal with. So that would mean that the user is going to need to input the length and the width of the wall that they're going to need. Okay, so if we were doing this kind of, you should be doing this ahead of time, right? Like there's no point writing the code and then going back and doing this. I mean, this is a process that helps you think about how to solve the problem. So we do it before we even touch a computer to try to figure out how to write the code in Python. So I need the length and the width. Okay. You should think about what type of numbers those might be. I'm thinking in this case, they'd probably be some type of floating point values, right? You're not necessarily going to get a even meter measurement for your wall, so some type of floating point values. Right, that's important because we need to do our conversions into float values when we actually write the Python code. Okay. And then I also think that we're probably going to need the number of coats that the person wants to put on the wall. And that will be an integer value because it doesn't make sense to put like 2.5 coats of paint on a wall. This is actually really even more important if you're using another programming language, because Python doesn't make you define the type of variable ahead of time, but other programming languages do. So if you're doing this problem-solving process, really you should be able to take this and code it in any language, not just using Python. Now, for the processing section, this is where we would figure out what kind of formulas we might need to use in order to actually solve the problem. So we're given information about the area that a bucket of paint costs. So it uses 4 meters squared of paint. So I do know, if we write that out, that the number of buckets would equal to the area divided by the 4 meters squared, because every can cover 4 meters squared. So that would just mean I need to find the area, and I think the area would be pretty straightforward calculation because it's a square wall, right? So we have a length and we have a width, and there could be more than one coat, so the area would just be the length times the width times the number of coats. Okay. And then, well, actually, one thing that we might need to do as well is round that number up, because we can't get a partial value of buckets, and we can't round down because then we won't have enough paint. So we need to round this value up in order to make it work. Okay, and then I also need to deal with the cost, but that's pretty straightforward because we're given the cost of a single can of paint, and that's $17.50. So we would have a subtotal before tax equal to the number of buckets times $17.50, right? And then our tax would be the subtotal times the rate of tax in Ontario, which we said was 13%. So that's 0.13, and then the total would just be the subtotal plus the tax. Okay. And then in terms of the output, I just have to kind of make it look nice, but I do need to print out the number of buckets and probably like a little receipt of the cost. So maybe we'll print out the subtotal, the tax, and the total. Okay, so just a bit of planning ahead of time will go a long way on simplifying how you're going to write the code to solve the problem. That's all we're really asking you to do for most of these questions, is just to think about it ahead of time. If you need to write some stuff down, write it down. Okay, don't just jump into coding and try to figure it out all as you go. Right? Think about it before you start. So now we are ready to maybe open up our development environment and start writing the code to accomplish this task. So let's open up Spider or whatever IDE you want to use, and we will start doing this. So the first thing we're going to do is let's add some comments to kind of help us through just kind of figuring out what's going on. So I need to get the input from the user. So remember, anything after this hashtag is not executed. It's just there to kind of guide us through the process. And so I need 3 inputs. So I need the length, and we decided that was a floating point value. And we need the width, which is also a floating point value. Oops. And we need the number of coats of paint, and that was going to be an integer. So enter how many coats. Okay, and we're just going to assume that the user is going to enter the proper type of value for our program. Okay, now I need to calculate the number of buckets. Okay, so we needed to do an area calculation first, which was the length times the width times the number of coats. And then our number of buckets was going to be equal to the area divided by 4. But I need to round this. So I can't actually use the way that we've been taught to round before, because that's just going to either round up or round down. I need to round up. So this is actually something that wasn't in the notes, but there is a function in the math library called a ceiling function. It is also called a floor function. So those will automatically either round up if you're talking about the ceiling, or round down if you're going to talk about the floor. So those are things that are available to you as well, but they're inside the math library. So I'm going to need to import math, and then I can apply that. So I can say math.ceiling, okay, the area divided by 4. Okay, so that's always going to round our division up in this case. And that's going to give me the number of buckets. All right, and now I can calculate the total cost. Okay, so our subtotal is going to be the number of buckets, times 1750, and it's going to then have a tax of the subtotal times 0.13, and a final total equals the subtotal plus the tax. Okay, and then finally I can output the total cost and number of buckets. Okay, so I think I'll make it, what did I say? It was going to be a little receipt, right? So I'm going to just make a space there so it looks nice, and we can print you will need buckets. Oops, forgot the quote. Of paint, and I don't know, maybe we'll just print out the final price instead. So the final price, if you want to print all three, go ahead, but in the interest of time in our video here, let's round the total to 2 decimal spots because we're dealing with a dollar figure, so that would make sense. Okay, so there is my written code. So what have I done so far? I planned out the solution using the input processing output model of problem solving. I've coded my solution. I've commented my solution, so somebody reading my program can kind of figure out what is going on. Right? The only thing I need to do now is evaluate or test my solution. All right? And all that really means is you just need to run your program and make sure it's working the way you think it should be working. And I guess the only way really to tell with this is you could get out your calculator and you could prove to me somehow that those calculations, if you were to do them by hand, were working correct. I mean, if you screw this up, okay, there's really not much you can do. I mean, if you screw up the math in your processing, you're going to screw up the math in your code, and it's never going to work, right? But you can at least verify that your code is working how you would expect it. If you want to get somebody else's opinion on whether you've done the math correct or not, then that's a good idea, because that will help you evaluate to see whether it is working properly. Right? So, I mean, you could pick numbers that might make sense, or that you could easily do the calculations on. Okay. So if I were to have a 7x6 wall with 2 coats of paint, I would need 21 of paint. So I need 21 buckets of paint. Okay. So that's something you should deal with. It would cost $415 and 27 cents. So these are in meters actually. So that's actually a pretty big wall. A 7 meter by 6 meter wall would be pretty big. So that's why you need 21 cans of paint and $400 to make it work. But you could check those values on the calculator and kind of see if it makes sense. All right. So that's what you need to do, and you're going to need to hand that stuff in when I ask you to do the problem solving for an evaluation. So I'm going to need to see the written out kind of input processing and output section, right, that you've done. You got to prove to me that you've done it. And you've got to prove to me that you did an evaluation. So that could be making a video of you actually testing your code, or it could just be kind of like screenshot the output with you doing some calculations by hand and kind of just writing some stuff about, hopefully showing that you've at least thought about whether your program was correct or not.